Okay, today's going to be really short because it's pretty much just a review. We're still in 4.2. We're just taking a second day on it. I guess that does usually happen when we are doing problems that are going to be tough on the test. So what makes a problem like this tough? Well, just because there's so many changes and so many things that can go wrong. With a stretch or a shrink, for example, people often don't know how to do these when the problems get difficult. I'm going to show you two ways. If you just graph y equals x squared for a minute, would everybody just put on the parent points of that? And if you don't know them, you could just use an xy chart and build them. If you had put in 0 here, you'd get 0. 0, 0 is definitely on it. If I put in 1, I'd get 1. If I put in 2, I get 4. If I put in negative 2, I get still positive 4. Negative 1 gives me positive 1. There's 5 points on x squared. If you don't know how to make them, just make a blank xy chart, stick in numbers for x, see what comes out. Now, couldn't I just do that same thing for this? Make an xy chart? Yes, that's what I tell my kids. Last year I told them just go directly to that. You don't have to memorize the parent points and then do like all these operations to them. Here's the problem if you want to do it that way. You make one mistake, like, oops, I went left instead of right, and all your answers would be wrong. Whereas, if you graph them on an XY chart, you use the XY chart, your best friend in graphing, and you make one mistake, hopefully you'll be able to go, oh, it was a square root, but then all of a sudden this point's over here. What the heck? I know it's supposed to be a square root. I must be doing that point wrong. And that point will kind of stick out as like an oops. All right, so how could you do it in a different way? Would you agree that the 2 here, I'm going to circle it and make it really obvious, that 2, that is on the outside and therefore it's a vertical change and therefore it's affecting the y. Can I just go and double all my y values? Yes, you absolutely can. If you take the parent points and then just double all the y values, that totally would work. Now you might say, I'd rather just make a new chart for this one. I agree, I would too. But I need to teach you this chart method because there are some functions that you don't know. You don't know what the equation is. Let me give you an example of that. Let's go to the next page. See this looks sort of like a slide with a little, I don't know, there's a little step area in there. A ramp with a step and another ramp. Well, that's not a function that you know. You don't have any oh, that's absolute value of x. You don't know what the equation is. So how are you supposed to, you can't make an xy chart directly. But what you can do is graph the parent points, chart the parent points with an xy chart. Everybody, let's make these parent points 0, 1, 2, 3, 4, 3, and 5, 5. And now, if I want to do this to it, we'll do it just like last time. That 2's on the outside. It's like a little process. First you say, is it inside or outside? And if it's horizontal, it's inside. And if it's out the outside, it's vertical. This one's on the outside, so it's vertical. That is a vertical change. So then, is it messing with the x or the y? Messing with the y. So I'm going to take all my y's and times them by 2. That's the only way to do this one. There's no other, as far as I know, there's no other option. You're going to have to take the parent points and then multiply by something or add something. So when's it going to get complicated? When there's stuff on the inside. My new points come out to 0, 2. Do you see that right here? And 2, 6, and you see that right here. And 4, 6 right there, and 5, 10, which is right there. Okay, so moral of the story. When there's a 2 out here, you would multiply all the y values by 2. Why am I saying that the inside is going to be more complicated? Let me show you one. Everybody write this one down, please. I'm back to a function that I know. It's not a mystery function anymore. This one's a parabola. And if I told you the parent points of the parabola, I think you'd probably remember them. 0, 0 as a point on the parabola. 1, 1, 2, 4, Negative 1, 1. Why not just finish it? Negative 2, 4. Inside's more complicated. Why? Because you got to do the opposite. And you got to do it in opposite order. You might think it won't matter. It will matter. Because do you get, if you add something like 1 and then double it, it's going to totally change it compared to doubling it first and then adding 1? It makes a difference. Okay, so you need to know what the right order is. And then you got to remember everything's backwards. Timesing by 2? No. Timesing by a half. Adding 1? No. Subtracting 1. So the inside's definitely more complicated. Now, my favorite way to do this one is just make an XY chart and go direct. Why am I not going to recommend that right this second? Because we're in the context of, remember this page over here? We didn't know these functions. These were mystery functions. If it's a mystery function, you have to make a table of values and then do stuff to it. So we're going to do this way where we take our table of values and do stuff to it. Who is going to tell me, since the inside is the kind that's difficult, what should I do first? Yes?
Make them into an equation?
You don't have to make them into an equation. Thank you for trying, but all I have to do is do something to all my x values. I don't need an equation for it. What do you think we should do to every x value? Subtract 1. Should I, wait, let's think about this. Should I first multiply it by 1/2? I mean, that's the normal order of operations. Oh, wait, we're not normal. Some of you aren't normal in the first place, so that works. But this is on the inside, so if it's on the inside, we do the opposite of normal. So we at least need to know what normal is so that we can do the opposite of that, and subtract 1 is correct. So I'm going to subtract 1 from all my x values. Minus 1. I'm going to do negative 1 plus, just because I can't squeeze them in the other way. So negative 1 plus negative 2, etc. And then when I'm done with all of those, then I'm going to go through and multiply everything by 1/2. So my new answer, I'm going to kind of spread out a little bit to the left, just because that's the side of the chart I'm on. And then I'd have negative 1, 0, negative 1, negative 2, and negative 3. And now I'm going to times them all by, what did I say again? 1/2. My final answers, negative 1/2, 0, negative 1/2, negative 1, and negative 3/2. And my x values, or sorry, my y values haven't changed yet. Yes?
Isn't 2 plus negative 1, 1?
Okay, I'm hearing multiple people saying that there's something wrong here. I'm trying to find it. Towards 2 plus negative 1.
Negative 1 plus 0 is the third x and the original.
No.
Not that one? Ah, this one. Okay, I see what you're talking about now. So I was like, no, that's right. Okay, this one is wrong. You're right. That's a positive 1. So I'm going to just make a little plus there. Here, I'll actually just use the eraser. There. Thank you. Now, that's exactly the kind of thing that I was talking about, where you make one little mistake, except usually the mistake is more like you add instead of subtract on like all of them. And then you can't even find it. Now, this one would have stuck out. All of the points would have been making a nice parabola, and all of a sudden one would be weird. And hopefully that point would have stuck out like a sore thumb, and you'd have noticed something was wrong, and you can go back and find it. But if you do this the wrong thing, like, oh, I added one and subtracted one to all the numbers, you won't even notice because it's going to form the parabola. It's just not going to be where it's supposed to be. So I don't like this method because it makes you be so careful on so many things. But it's the only way we have if it's a mystery function. Yes?
Couldn't you just have said the original x equal to the inside?
Yes, you can do that same technique that we used to do, but this is not an equation. I'm not saying it would be wrong, but you're going to have to generate a new point for each of them. Get what I'm saying? All right. So, yes, but it wouldn't save you time because you'd still have to do each step to each number. Do you get what I'm saying? Okay. So that wouldn't be like a huge time saver, but it would be accurate, yes. Okay, so now, what about the y's? The nice thing about the y's is you can trust them. So all I got to do is times by 3 and add 8, and it's that simple. Does the order matter? Yes, it does. Should I add or multiply first? Multiply first, because it's the normal order of operations. So I'm going to multiply by 3 and then add 8. What is 0 times 3 plus 8? It is 8. What is 1 times 3 plus 8? It is 3, 8, 11. What is times 3 plus 8? That's going to be 12 plus 8, 20. 1 times 3 plus 8, back to 11. And times 3 plus 8, since those are the same as above, it's still going to be 20. And now, finally, after all of that, I've got my x values and my y values. And if I graph them, I will find a parabola that's had all these 4 changes done to it. Sorry, not a parabola. This one wasn't. Well, yeah, this one was a parabola. But the section we're in right now is for mystery functions. So we'd have to be given the original stair-step shape, or on your homework there's going to be a couple where it's the letter M. You don't know a function to make the letter M, so mystery function. Okay, that pretty much sums up the thing for today. And that's write down the parent points, do something to the parent points, careful on the inside that you're doing the opposite in the opposite order. All right, so what's your homework look like? This kind of thing, mystery function, I could list the points on an XY chart, and then this half on the inside messes with the x's or the y's? X's, and is it going to times by 1/2 or times by 2? Times by 2. Then what should happen to this thing? Should it get narrower or wider? I marked this wrong a ton because people just get it in their head that, okay, it's half as big, so it's narrower. Here on the inside, everything's the opposite of what you think. This one's going to be wider. It's going to go out to here. So some people go, okay, so my M is stretched out, but then they make it like half as tall also. It's got to be the same height as the original. And it's got to get twice as wide. So roughly, and it's got to be the same height as the original, but twice as wide. There. That is the same height as the original, but twice as wide. So I never had to actually make a list of all the points and multiply all of their x values by 2, but if I had, that's what would have happened. Okay. What's this saying? It's just the same slide as before, but it's saying if we're horizontal, then small numbers make it stretch, and numbers bigger than 1 make it shrink, because they're just describing what happens on the inside. And we've gone through that pretty thoroughly. So let's get to your homework. Your homework for today has some questions like this where you have to make the equation. I hope you would find this to be pretty easy. I've got to have a parabola that's being shifted up 2. Well, and I put a plus 2 at the end. What else does it have? Oh, a reflection across the x-axis Over the x-axis. I'm going to draw it for a second. It goes over the x. This is the x-axis. This is the y. If it's going over the x, that's a vertical change. If it's vertical, it's on the outside. There's a negative out here. Horizontal shift right 1 unit, -1. And horizontal stretch factor of 2. I'm going to do two things wrong at once right now. I put a 2 right there. That's wrong twice. Why? It said horizontal factor 2. Why can't I do that? Because it should be a 1/2. And there's another thing wrong with it. Does anybody remember? Yes, parentheses. If you don't have the parentheses, it won't work. Now, you guys are smart enough to deal with this. It's complicated. We math teachers have not arguments, but discussions all the time about the inside. Okay, well, what are you going to do on the inside? How are we going to describe this to them? Because why do we have to have the parentheses? Well, I know you know it's different if there's parentheses in there. You know that, right? Because it's going to distribute to 1/2. So here's the fundamental problem that I think I can do with you guys because you're pretty smart. I'm trying to get at, let's say I have an absolute value. We have this versus this. They are not the same thing. Okay, they don't go to the same place. Why? Because this one is going to, since the parentheses are in there, it's going to be forcing me to do the 2 first. It's going to cut my values in half and then move to the right one. Versus this one is going to ask me to move to the right one and then cut it in half. All right, so I'm going to give you one last example of this. I'm going to use those same thing, except I'm going to show you, I think this is the easiest way to describe it. Let's say I say 2x minus 1, and then, do you get if I factor it, these will be equal to each other if I factor out the 2? But what would I have to put here? It wouldn't be a 1, would it? What would it be? Do you get that those are equal to each other? And you know that moving to the right one versus moving to the right 1/2 is not the same thing. And yet, you're going to end up in the same spot. Why? Because one of them's going to stretch it first, and the other one's going to move it first and then stretch it. So if we put in a number in, like 3, if I'm really right that these are the same thing, if I put in a 3 here or here, I should get the same answer. And I will. Times this by 3 makes 6, subtract 1, that makes 5. That's going to give me 2.5. Double it, still going to get the 5. You're going to get the same point either way. All right, so those two, these two, the same. So be careful with parentheses. When you're building them, make sure to build them with parentheses. That's the way that you're used to, and it'll work right if you stick parentheses in when you're building them. All right. I know that's complicated. Let's get to the homework for today. This is, the whole theme is just like do yesterday except with harder numbers, more complicated drawings. All right, so this is going to be these 3 crossing off those. So you're going to do 11, 14, and 17. On this one, I think we can get away with just doing 2 of them. We're going to do the ones on the right side here again and cross off the ones on the left. Some of you might recognize that. Do you get that that's a half circle that's being graphed? 2-second stretch the smart kids thing. The radius of that one was 3. Do you get that a real circle is not a function, but a half circle is a function? So how do you get the equation for a half circle? Somebody smart, figure out what I should do with this equation. What about squaring? What about square rooting? What am I going to square root? Hint, I need to do something first. Solve for what? Solve for y. Okay, everybody, solve for y. Y squared equals 9 minus x squared. Square root, square root. Absolute value of y, if you remembered that. Why does that matter? Because it's going to give us 2 equations for it. Let's think about these 2 equations for it for a second. Square root of 9 minus x squared is one of the equations. What's the other equation? Negative square root of 9 minus x squared, and that negative is actually making your half circle get flipped over. So the first half circle looks like this, and the other half circle is a flipped over circle like that. So a circle is really made up of 2 functions. The top half of the circle and the bottom half of the circle. That's the top half of the circle. That's the bottom half of the circle. If you break it into 2 half circles, then they're both functions. All right, so if you wanted to know the equation for this half circle right here, it's right here. That's the equation for a half circle. And half circles are functions. Okay, you don't have to do that. Unless you do have to do that on the test. You don't have to do it today. Today they just want you to take this function and move it, stretch it, that kind of stuff. Okay, and I think there's more page. This page, just let's do one of them, lucky number 55. Now, I'm going to mention that, remember, I've been having you skip a decent chunk of your homework, and I think it's working for a lot of you. This is not the only thing that affects your scores in math, of course, but it's a piece. If I had been assigning all, some of you would have been dutifully doing all of them. And the question is whether that means you might have been doing better. If you have an A in here right now, I'm not too concerned about you needing to do better. But what if you've got a B going or a C? Well, maybe it's hurting you that I'm not assigning all of them. But I'm not going to like say, hey, you, with the C, you have to do twice as much homework as everybody else. But you could do that to yourself. It's up to you. Just saying, if you're not getting enough practice, then there's no reason that you couldn't do these for practice. That would be just smart, mature. You could decide. It's your life. I'm just trying to make you realize that I am assigning a subset. And if you had more practice, some of you might actually benefit from that. So you get to decide whether you assign yourself more homework. Don't just do it because you think it'll make yourself a better person. Do it if your grade in here isn't what you want it to be. And this is one more thing you could try to make it better. Okay, and that's all I have for you for today. All right, the rest of the time is yours.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct.